In addition to sodium-ion and lithium-iron manganese phosphate (LFMP) batteries, there are several other alternative battery technologies that offer the potential to address the limitations and environmental impacts of lithium-ion batteries. These include solid-state, zinc-air, redox flow, metal-air, and lithium-sulfur batteries. Solid-state batteries use a solid electrolyte instead of a liquid electrolyte, which can increase the energy density and reduce the risk of thermal runaway, a phenomenon in which overheating can cause a battery to catch fire. However, solid-state batteries are still in the early stages of development, and there are several technical challenges that need to be overcome, including the need for a high-performance solid electrolyte. Zinc-air batteries use zinc and oxygen to produce electricity, which can make them cheaper and more environmentally friendly than traditional batteries. However, zinc-air batteries are currently limited by their low energy density, and research is needed to improve their performance. Redox flow batteries use two electrolyte solutions, which can be stored separately and pumped through the battery when needed. This can make them ideal for large-scale energy storage, such as for renewable energy sources. However, redox flow batteries are currently limited by their low energy density, and research is needed to improve their performance. Metal-air batteries use a metal such as aluminum or magnesium as an anode and oxygen as a cathode, which can make them lightweight and high energy. However, metal-air batteries are currently limited by their short lifespan and the need for an airtight design to prevent the battery from reacting with the environment. Lithium-sulfur batteries use sulfur as a cathode instead of cobalt, which can make them more environmentally friendly and less expensive. However, lithium-sulfur batteries are currently limited by their short lifespan and the need for a high-performance electrolyte. While each of these alternative battery technologies has its own unique strengths and challenges, they all offer the potential for increased energy density, longer battery life, and reduced environmental impact. However, significant research and development is still needed to make these alternative technologies commercially viable and accessible to the general public. Continued investment in alternative battery technologies can help accelerate the transition to a more sustainable and just energy system. The widespread adoption of sustainable energy sources such as wind and solar power is a crucial part of the transition to a more sustainable and just future. However, for renewable energy sources to become truly viable alternatives to fossil fuels, they must be able to provide reliable and consistent power. This is where energy storage systems, ES, come in. ES are a critical part of the renewable energy system, as they allow excess energy to be stored and used when needed. This can help overcome the intermittency of renewable energy sources, ensuring that energy is available even when the wind isn't blowing or the sun isn't shining. In recent years, there has been significant progress in the development of ES. Lithium-ion batteries have emerged as the most common and commercially available ES technology. However, as we have discussed, the production and disposal of lithium-ion batteries have significant environmental impacts, and the mining of lithium is associated with habitat destruction, water depletion, and air and water pollution. The development of alternative battery technologies such as those discussed in Topic 4 can help address the limitations and environmental impacts of lithium-ion batteries, making ES more sustainable and accessible. In addition, the implementation of a circular economy for batteries, as discussed in Topic 3, can help reduce the environmental impact of battery production and disposal, and extend the lifespan of batteries. The future of ES is also closely linked to the development of smart grid technologies, which can help optimize the use of energy and balance supply and demand in real time. By combining ES with smart grid technologies, we can create a more efficient and reliable energy system, and accelerate the transition to a more sustainable and just future. In conclusion, the development of alternative battery technologies in ES is crucial for the widespread adoption of renewable energy sources, and the transition to a more sustainable and just future. Continued investment in research and development of sustainable batteries, the implementation of a circular economy for batteries, and the integration of ES with smart grid technologies can help ensure that the transition to a sustainable energy system is both feasible and equitable.